Have you ever noticed something strange about the sun and moon when they are near the horizon? They often appear flattened, almost squashed. The sun might look like a giant orange pancake, and the moon like a silver coin stuck on the edge of the sky. This peculiar phenomenon has puzzled observers for centuries, prompting countless theories and explanations. One of the key factors at play is atmospheric refraction. This phenomenon is responsible for many of the beautiful and intriguing visual effects we observe in the sky. When we look at the sun setting or the moon rising, we are actually seeing them slightly displaced from their true positions due to the bending of light. Light from the sun and moon doesn't travel in a perfectly straight line, especially when passing through Earth's atmosphere. The atmosphere is composed of layers with varying densities, and as light passes through these layers, it changes direction. This bending of light is what we call refraction. The atmosphere acts like a giant lens, bending the light rays as they travel through different layers of air density. Each layer of the atmosphere has a different temperature and pressure, which affects the density of the air. As light moves from one layer to another, it bends slightly, creating a cumulative effect that can significantly alter the path of the light. Imagine a straw in a glass of water. This simple experiment can help us understand atmospheric refraction. When you look at the straw from the side, it appears to be bent at the point where it enters the water. The straw appears bent at the point where it enters the water. This is because light travels at different speeds in water and air, causing the light rays to bend. The same principle applies to the light from celestial objects as it passes through the Earth's atmosphere. This is because light travels at different speeds in water and air, causing the light rays to bend. When light enters a denser medium, it slows down and bends towards the normal line. Conversely, when it exits into a less dense medium, it speeds up and bends away from the normal. This bending effect is what causes the straw to appear bent. Similarly, the Earth's atmosphere bends the light from celestial objects, altering their apparent shape and position. This is why the sun appears flattened when it is near the horizon, and why the moon can look larger and distorted. Atmospheric refraction not only affects the position and shape of celestial bodies, but also contributes to phenomena like the green flash at sunset or sunrise, where a brief green spot is visible just above the sun. Our brains also play a role in how we perceive the shape of the sun and moon at the horizon. This phenomenon is not just a simple trick of the eye, but a complex interaction between our visual system and the environment around us. When we look at the horizon, our brain is bombarded with a multitude of visual cues that it must process and interpret. These cues help us make sense of the world, but they can also lead to fascinating optical illusions. Our visual system relies on cues from the surrounding environment to judge size and distance. For instance, when we see a tree or a building, our brain uses these objects as reference points to determine how far away other objects are and how large they appear. This process is usually quite accurate, but it can be easily fooled under certain conditions. When the sun or moon is low in the sky, our brain compares its size to familiar objects on the horizon, like trees, buildings, or mountains. This comparison is crucial because it provides a sense of scale. Without these reference points, it would be much harder for us to judge the size and distance of objects in our environment. However, this comparison can also lead to some interesting visual effects. This comparison leads to an optical illusion known as the Ponzo illusion. Named after the Italian psychologist Mario Ponzo, this illusion demonstrates how our perception of size can be distorted by the context in which an object is seen. In the case of the sun or moon at the horizon, the presence of converging lines, such as roads or railway tracks, can make these celestial bodies appear much larger than they actually are. In this illusion, our brain perceives objects placed along converging lines as larger or smaller depending on their position. For example, an object placed at the point where the lines converge will appear larger than an object placed closer to the viewer. This effect is due to the way our brain interprets perspective and depth cues. Similarly, when the sun or moon is near the horizon, our brain interprets its size as larger due to the presence of these visual cues. The trees, buildings, and mountains provide a frame of reference that makes the sun or moon appear much larger than when it is high in the sky. This fascinating interplay between our visual system and the environment is a testament to the complexity of human perception. While Earth's curvature itself doesn't directly cause the sun and moon to appear flattened, it does contribute to the overall effect. The curvature of the Earth plays a role in how we perceive celestial objects, especially when they are near the horizon. As the Earth curves away from us, the angle at which we view the sun and moon changes. This change in angle means that the light from these objects has to pass through more of the Earth's atmosphere. The atmosphere through which we view celestial objects becomes thicker near the horizon. This thicker layer of air is filled with particles and gases that scatter and refract light. This thicker layer of air enhances the effects of atmospheric refraction, bending the light in such a way that it distorts the shape of the sun and moon. Further distorting the light from the sun and moon, this refraction can make these celestial bodies appear squashed or stretched. Imagine looking down a very long, straight road. The road appears to converge in the distance due to Earth's curvature. This is a simple example of how perspective and curvature can affect our perception. Similarly, the increasing thickness of the atmosphere near the horizon amplifies the bending of light, creating a mirage-like effect. This bending of light is more pronounced when the sun or moon is low in the sky, making them appear flattened or elongated. Creating the illusion of a flattened sun or moon, this phenomenon is a beautiful reminder of the complex interplay between our planet and the cosmos. The next time you see a sunset or moonrise, take a moment to appreciate the subtle influence of Earth's curvature and atmosphere on the celestial show. Section 5. Fun facts from the cosmos, intriguing tidbits. Did you know that atmospheric refraction also explains why the sky is blue? The Earth's atmosphere scatters sunlight, and blue light is scattered more than other colors. This scattered blue light is what we see when we look up at the sky. Another fun fact, the moon doesn't emit its own light, it reflects sunlight. The different phases of the moon are caused by the changing angles at which we see the sunlit portion of its surface. Section 6. Debunking the myths, common misconceptions. One common misconception is that the sun and moon appear larger at the horizon because they are closer to Earth at that time. However, this is not true. The distance between Earth and the sun or moon doesn't change significantly throughout the day. Another myth is that the flattening effect is caused by the Earth's atmosphere acting like a magnifying glass. While the atmosphere does bend light, it doesn't magnify the sun or moon. Section 7. The Grand Illusion Unveiled. A synthesis of factors. The apparent flattening of the sun and moon near the horizon is a fascinating phenomenon that arises from a combination of factors. Atmospheric refraction bends the light from these celestial objects, while our brain's perception of size and distance is influenced by optical illusions and the surrounding environment. Understanding these factors helps us appreciate the complex interplay between light, our atmosphere, and our own perception. The next time you witness a flattened sun or moon, remember that you are observing a beautiful example of the universe's ability to surprise and amaze us. Section 8. Beyond the Horizon, Expanding Our Cosmic Perspective. The curious case of the flattened sun and moon serves as a reminder that our perception of the universe is shaped by both physical phenomena and our own sensory experiences. By exploring these phenomena, we gain a deeper understanding of the cosmos and our place within it. From the bending of light to the workings of our brains, the universe is full of wonders waiting to be discovered. By embracing curiosity and scientific inquiry, we can continue to unravel the mysteries of the cosmos and expand our cosmic perspective. Section 9. A final thought, appreciating the wonders above. So the next time you find yourself gazing at the celestial tapestry above, take a moment to appreciate the intricate dance of light and perception that shapes our view of the cosmos. The flattened sun and moon are not merely optical illusions, but rather captivating reminders of the awe-inspiring beauty and complexity of the universe we inhabit.